Good afternoon. Thanks for joining us for this webinar. This is the second of two webinars. The previous webinar we gave last week was titled IBM Ported Tools for ZOS OpenSSH Key Authentication. That is now up on our website. You can download it and look at the slides if you'd like to. And as soon as we finish presenting this one, we'll put it up on the website as well. So without further ado, I'm going to turn it over to Kirk, who's going to take you through IBM Ported Tools for ZOS OpenSSH using key rings. Kirk?
Hi, thanks, Steve. Again, so here's the URL at the bottom of our webinars page. Also on that page, you can subscribe to our mailing list, our email list. We send out notices every month or two about new releases or webinar announcements, things like that. So you might want to check that out. Here's a little bit about who we are. We kind of covered this last week. I'm not going to spend much time on it. I'll just mention our primary product right these days is the big thing that we're working on mostly is a Cozy co-processing toolkit for ZOS. It has a number of components, most popular of which is Cozy SFTP, which is our port of OpenSSH SFTP components, just the SFTP parts of OpenSSH. And to that port, we've added a whole bunch of exploitation for ZOS, so things like data sets and spool files and dynamic allocation and stuff like that is all supported in Cozy SFTP. You know, similar to, on par to the kind of legacy ZOS support you see in, say, IBM FTP. These components that have an asterisk here actually require, I just make a note of this, require that you have IBM Ported Tools OpenSSH, because what we don't do is we don't include in Cozy our own port of the underlying SSH layer of OpenSSH. So we rely on you using IBM Ported Tools OpenSSH, which is it's a non-chargeable program product for ZOS. So you kind of have to have that to use nearly all this stuff. Speaking of Ported Tools OpenSSH, this is a bit of a review from last time. I just wanted to throw it up here just to kind of just to touch upon it just a little bit. Recall that being a port of OpenSSH, it has all the familiar stuff that you would see in any OpenSSH implementation. So if you looked at OpenSSH on Linux or Unix or even Windows under Cygwin, you would see these commands. Under ZOS, these are ZOS Unix commands. There's the SSH client, the SSHD server, the SFTP commands, which kind of use those, and the other things, some of which we'll talk about today. The SFTP parts of IBM's port, this node, do not include support for MBS datasets and spool files. That's sort of where Cozy SFTP comes in, and that's why it's become popular for doing that kind of thing. Now, I want to touch on this presentation today is mostly about this bullet under support that was added in Release 1.2. So back a couple years ago in Release 1.2, IBM added support for putting your SSH key material in a certificate in a SAF or RACF key ring. And we're going to show you how to use that and talk about some of the advantages of doing that. Okay, so this is mostly review from last time. I'm just going to skip along. We're going to get started with the agenda today. First of all, we're going to review a little bit how SSH key authentication works, just sort of just to refresh your memory from last week, from part one. And specifically, we're going to talk about, along with that, how you need to protect key material, your private keys and your public keys, what you have to do to protect the private keys and the registries that sort of use the public keys, right? That's going to lead into a discussion of why you would want to use digital certificates with SSH. In other words, when we talk about protecting your key material, that's going to primarily, you'll see, be one of the main benefits of why you would want to use RACF key rings, or your security product, ACF2 or Top Secret also supports key rings. why you would want to use key rings with SSH. So then we're going to jump right in and we're going to show some RACF examples of how to create a digital certificate and a key ring for using your private key for either a user key, user private public key pair, or for the server host key private public key pair. We'll show you how to do that with RACF. And as part of getting that, the private key, of course, would be in RACF or the database or even ICSF. We're going to show you, along with that, how once you get it in there, once you generate it inside of RACF or Top Secret or ACF2, how you could get the OpenSSH format public key out of it. So just like when we created an OpenSSH public-private key pair just in a file system like last time, we had that OpenSSH formatted public key file that we needed to send to our partner so that they could register our private key and set up the authentication. Well, we still have to get that file somehow out of the RACF certificate. We'll show you how to do that. Then we'll show you how to use, actually in an SFTP session or an SSH session, how to use the private key in a key ring with OpenSSH. And finally, we'll talk about some of the rules, the permissions, the RACF SAF permissions that you need in order to use a certificate, in order for your end users to use their key that's stored in a certificate that's stored in a key ring. After that, we're going to talk about an extension to this whole thing where you might want to, under certain situations, store for user keys, put your private key in ICSF protected hardware. So in other words, into a PKDS, I think is what it's called, the hardware token. So if you have a coprocessor card where you can store keys in a token, you might want to store your private keys in there. And we're going to talk about some of the reasons why you might want to do that and how it works, because as we'll see, there's kind of a catch-22 here that we have a solution for. And we're going to wrap up today with a high-level discussion, sort of tying everything together on best practices for using keys, both kinds of authentication, both how to manage your known hosts, which we talked a lot about last time, and also, the best practices for using keys, both host keys and user keys. Okay, so before we jump in, this is sort of a disclaimer. In this presentation, we're just going to demonstrate the RACF commands for creating key rings and certificates. However, Ported Tools OpenSSH, it uses standard interfaces. It uses SAF and it uses specifically the RDataLib interface to get at key rings and certificates. So because of that, security products that conform to those interfaces, in particular ACF2 and Top Secret, also have support for this, and they will work with Ported Tools OpenSSH. You just simply have to take the you simply have to take the RACF commands, the RACDcert commands, and sort of map those into the appropriate command in your security product. Okay, so this is a review slide from last time. I'm just going to put it up here just to kind of level set. As you recall, we talked about the two kinds of authentication. There's the authentication that the host, or sometimes called the server authentication. This is where the server proves who he is, so that you couldn't have a man-in-the-middle attack and have some other server pretend to be the server you want to go to, which would be bad. And this is done by the server, specifically SSHD is the server component of SSH. He has one or more private keys, and clients would have a matching public key in a registry. This registry file is called known hosts, and there's two different versions, if you remember. The user's specific one and the global one. On each client machine you have this. And this registry associates the host name or the IP address with this public key. So when the client connects, he can verify that. And if you don't have that, as you've seen, if you use this, it prompts you to say, well, here's the public key that this server is using. Here's his fingerprint. Do you want to accept this? Do you want to trust this now? And then it would put this in your client user ID's known host file, and then you would have it there for next time. So with user key authentication, this is where you want to have the user authenticate that he has the credentials to use a user ID on that foreign host, on that target host. The roles are reversed. In that case, the user has the private key, so I'm sort of keeping the private key material in red here, and the public key is kind of in green. The server has the green stuff, the public key. In this case, the registry for the public key is $home. This is the target home directory, the .ssh directory under that. A file called authorized keys has a list of all the public keys that are allowed to log in as that user with SSHD. So what does that mean? That means that if you have a private key that matches a public key in this list, then you can authenticate as a user and log in without a password to that machine. Okay. As I go along, I'll mention this is a re-recording of a broadcast that we did. In fact, we messed up the recording, so we're re-recording this. So if you have any questions about this, if you're looking at this, I'll review this again at the end. But you can post a question on our community bulletin board, or if you're a commercial customer, you can open a ticket and ask us a question. Either way, but I'll give you the links to those at the end. All right. So. Safeguarding private key material. We talked about this, but just to review, for the host private key, this is the host authentication, the first part, only root, only UID 0 should be able to read that private key. And that's because SSHD, the part of SSHD that the front end part that does authentication, he runs as UID 0. Before you log in, it's running as UID 0, and that's the only user ID that should be able to read that host private key. Because if someone else could read it, they could send it to their friends, and then anybody could impersonate that host. Similarly, with user authentication, only the client user ID. So on that machine, only the user ID that under the client system's user ID that's going to use that key, only he should be able to read the user private key, because otherwise, if somebody else could read it, they could make a copy and they could send it to their friends, and then anybody could log into that remote server with that private key. So here's a little note. This is a little note that says, well, it's even better if the user can't read it. Huh? That sounds nonsensical. I mean, how can the user use it if he can't read it? Well, we're going to talk about that because it's kind of an important concept with using keys. On the other side, on the green side of the ledger, these registries that have the public keys, you need to safeguard those too, but the safeguarding is a little different because, let me point out this if it wasn't clear last time, there's really never a danger. There's never a problem with allowing someone to see a public key. You can, email your friends your public keys. You can post them on the bulletin board. You can do anything you want. It never is harmful to allow someone to see a public key, because that public key doesn't really allow you to do anything except authenticate someone who has the private key. You can't use the public key to get the private key. You can't do anything else with it. But the registry files that sort of register that this public key is going to mean something, those files, those need to be protected from update. So on the client for, this is, again, for host authentication, the client has known hosts, or it has the global known host file. Those files that have the public keys that register the private keys of the servers you're going to, these files only need to be updatable by the client user ID, or by root in the case of the second one. Turning it around, looking at user authentication, the target user IDs .ssh directory, this file authorized keys, you're going to make sure that only the target user ID, the owner of this file, of this directory, only that guy should be able to update this file. Because if someone else could update it, they could put a public key in there, and then that matched some private key that they had, and then they could log in, right? So you got to make sure that even though it's okay to let someone read these files, you can't allow anybody else to update them, to put things in these files, to put a key in the file. So if you recall, there was a slide on the part 1 called Common Pitfalls, that actually one of the pitfalls is not having these files set up with right permissions, because OpenSSH, actually, if they're not set up with the right permission bits, won't even allow you to use them. It'll just ignore these files. So in particular, authorized keys, sometimes people step in that pitfall. So look at that slide on first presentation. It gives you all of the detailed permission settings for these files. Okay, so now that we've talked about the just sort of reviewed a little bit about the normal key authentication, let's talk about digital certificates. And the main point, the main reason why people are interested in putting their say their private key material into a certificate, and in fact, the private key doesn't really go in the certificate per se. When you create a digital certificate with a public-private key pair, the private key pair is really stored in, by default, the RACF database. So the private key is stored in encrypted form in the RACF database by default. But this has, to most people's minds, a big advantage. It's not in a Unix file system where you have to worry about permission bits and allowing people that have root authority or UID 0 to read it and things like that. It's much better to have these credentials, in my mind, and I think in most ZOS security administrators' minds, it's much better to have this private key material in RACF database or in your security system, in your security manager. Now, even better than that is you can put the private keys in ICSF in a hardware token. And when you do that, it's even better because the user ID can't read the private key, but the user ID can use it. Sorry, I hit the key there. The user ID can use the private key. He can actually make an API call to do something with the private key. Well, what does he want to do with it? What he wants to do with it is he wants to make a signature. He wants to sign that authentication request. So the user can call an API, even if an ICSF API, even if the private key is in hardware, he can use the private key to make a signature, even though he can't grab it out. He can't get the private key, he can't see it, but he can use it. And that's kind of cool. Now, the downside of this is that IBM Ported Tools OpenSSH doesn't currently support this directly. You can't put your private keys in hardware. Their current implementation is, unfortunately, they require that they need to be able to read the private key out, and then they use it like they do any other private keys. But the good news is that IBM Ported Tools OpenSSH does support a protocol called the it supports a protocol called the SSH Agent Protocol, and Cozy includes this program called SAF SSH Agent, which can be used with Ported Tools to allow you to do this, because this program does use all of these APIs, so it doesn't need to read the private key to use it. And this program will allow you to use user keys, not host keys, but user keys, even if the private key is in hardware. So we'll talk about that later. I'll mention this. Ported Tools OpenSSH can also use public keys, just the registry side, the public key side. He can put the public key in a certificate. So the way this works is in your known hosts file or in your authorized keys file, instead of having the public key, you can have this level of indirection. You can have a pointer to a certificate that contains the public key. Now, to my mind, this isn't that exciting, because you still have these files that you need to protect, and you're just putting this level of indirection. I mean, it just doesn't have that big of a bang for the buck for me to do that. So we're not going to cover that in this presentation. Now, there are some possible cases that you might want to look at that. There's a posting on our forum recently about a special case where you might want to do this, and the details are in there. But we're not going to cover that here because I think most people don't. This is not the big hit, the heavy hitter here. Your private keys, however, putting those in a key ring and putting those in your security manager, that's a big deal. Now I want to point out that the SSH RFC, the standard, right, the standard SSH, across the wire, it uses asymmetric key processing to do this authentication, but it's not SSL, right? We had a question last time about that. It's not SSL, and in fact, it doesn't use X509 certificate chains. So even though what we're doing is storing the SSH key material in an X509 certificate in RACF, when it comes down to it, Ported Tools is not using X509 protocols across the wire to do certificates. So that means you don't have to worry about setting up a certificate authority. And in fact, for purposes of using keys in OpenSSH, a self-signed certificates are just fine. Certificates authorities and chains, CA chains, and those kinds of things are not really used by OpenSSH at all, right? Okay, so let's look at now, since we've talked about some of the advantages of using digital certificates on ZOS for your SSH keys, let's look at an example of how you would do this in RACF. So here are some commands. The first command is the important one. This actually, RACDcert is the RACF command for dealing with digital certificates. You'll notice all the commands, the first thing I put up front is the ID. This is the user ID of the owner of the certificate or the owner of the keyring. So when you look at certificates or key rings, all certificates and key rings are scoped under some owner, some user ID that owns it. So I always put that first. So these commands would typically be executed by the security administrator. That is, some user ID that has RACF special authority, or it has a set of permissions that allow him to create certificates. Your end users typically don't have those permissions. So some administrator says, okay, I'm going to create a certificate for Alice. I'm going to generate the certificate, and here are the distinguished name fields. Now I've only put in this example because of space, just the one. I just put the name field in here. But in the real example I'll show you in a minute, you can see you can put all of the DN fields just like you're creating if you're creating an SSL certificate. The important thing about this DN is that underneath this user ID, you can't have more than one certificate that has the same exact distinguished name. So you'd have to have unique distinguished names under the same user ID. By default, the certificate is going to be an RSA certificate. It's going to use the RSA algorithm, which is probably the one you want to use anyway. It's the most widely implemented. And on ZOS, you'll see that if you're using some of our stuff, you can actually use a coprocessor if you have one to do the RSA operation. So with RSA, which is the default, this is the key size in bits. And then I've also specified not after, which if you don't specify not after, you can give it an expiration date. It'll expire in 1 year, and then you got to deal with, either renewing it or creating a new key pair and distributing all that stuff. So I usually make these last a little bit longer. With label, this is the key thing. This gives you the label or an identifier to identify the certificate, and this label can be like up to 32 characters with spaces and all kinds of stuff. Now I tend to restrict the character set of my labels to be like data set names because, as you'll see, if you want to put it in hardware, this label can also be used to refer to the token name, and the character set restrictions on that are much smaller. So I typically don't get too fancy with my labels. And also this label name needs to be unique within this user ID. So the name needs to be unique within the user ID, and the label needs to be unique to identify this certificate uniquely within this user ID. traditionally what you do, and you had to do this up until I think 1.11 of ZOS. Traditionally, then you have to create a key ring underneath this user ID. So this name of this key ring has to be unique under this user ID. And then you connect this label, this certificate, to the key ring for this user ID. So these last two things have to do with taking and making a key ring and connecting the certificate to that key ring. I'll mention that the certificate now that we have, you can reference it by this string. This is the format of the string that OpenSSH uses. User ID / right, and then the key ring name and space, and then the label name. Right, it's got to have the space in there. And that's the format referring to it. You'll see also that if you're referring to a key ring, you don't need to specify Alice if you're referring to it from within a job that is using the user ID Alice. So that's only, defaults to the current user ID, in other words. Okay, so once I have that certificate in there, I need to get the public key out so that I can send it over to, let's say if I'm doing user authentication, so I can send it over to the target system and maybe put it in authorized keys, right? So let's talk about how to get the public key out of the certificate I just created. So here's how you do it using the OpenSSH, the ZOS Ported Tools OpenSSH command. This is the SSH-keygen command, and that's a command that's on all OpenSSH implementations, but it's been extended by IBM on ZOS. It has this -e, so you can export a public key, and it'll export the public key from a key ring if you export this environment variable and set it to this name of the certificate. So the user ID, if it's not the current one, the name of the key ring, space, and then the label name of the certificate. You set that environment variable, you can export it to a file, right? Now this file is not an OpenSSH, that OpenSSH single line format public key that we've seen before. It's not that format. It's a multi-line format. It's in a standard format called RFC 4716, a standard format for exporting public keys. So if you want to put that public key into an OpenSSH on the target system, if you want to put it in your authorized keys, you got to convert it. So SSH keygen on the target system, you can take this format file, -i for import it, give the file name, and then it'll actually print out the OpenSSH format public key, the one-line thing, and we'll just concatenate that to the end of the authorized keys file. So this is how you would do it on the target system. Convert this format file to this one-line public key file that OpenSSH uses. Now, a shortcut way of doing this is this command that comes with Cozy SFTP or with the Cozy toolkit, saf-ssh-agent. You can just say -x for export. Here's the name of the file I want to create, and then you give the public key name, Alice / or omit that if it's a current user ID. Now, we use the systems SSL syntax for this, which is much more convenient. Instead of a space, you can put a colon in front of the label name. So it's slightly different syntax for the label name, and this will directly create this file in OpenSSH, the one-line public key format that you would get if you did a SSH keygen command the old way, right? I'll show you how that works. So here's a diagram, kind of like the last week's diagram, but this is a diagram looking at user authentication using a RACF keyring. We have a client system using the SSH client. Here's a server called My Server running SSHD. We're going to use an SSH into the user ID R user on this remote system. On the client, we've defined a public key in a RACF keyring. And I've exported it into ssh01.pub. I've gotten the OpenSSH format public key. I take that file and I move it over to the server, and I take that one line and I tack it onto the end of my authorized keys file. And here's what it looks like. It's one of those it starts off with a key type, and then it has the big long base 64 encoded public key. So I've set this up. And then on the client side, I have to tell Ported Tools OpenSSH to use this keyring and this label. So one way to do that is there's a ZOS-specific user configuration file you can put in your home SSH directory on the client. And in this configuration file, you can say identity keyring label equals, and you got to have double quotes, and you got to have the space. I can omit the user ID / because it's my keyring. It has to be my keyring for me to be able to use it. And then this, having set this up, it'll automatically try to use this keyring anytime I make an SSH connection. Now, if the target system doesn't have an authorized key, it's going to fail that. It's going to go on and prompt me for a password or try a different key or something. But I can automatically use it anytime I want if I set it up this way. Now, this identity keyring label, you can also specify this on the command line for an SSH or SFTP command. I could specify it on the command line if I wanted to use a different keyring or a different certificate for each connection or something like that. All right, so here's a nice simplification. Here's a nice simplification. I can't think it came along with RACF and ZOS in 1.11, I think. And this is virtual keyrings. It turns out with there's a thing called a virtual keyring, and each user has one, and it's sort of the default keyring. Meaning that anytime you create a certificate, kind of a personal certificate, not a CA certificate, that doesn't count. A personal certificate, like we're using, it's automatically connected to this thing called the virtual keyring. And you can refer to that virtual keyring, instead of the name of it, it's called asterisk. So you can just say, if I'm referring to someone else's virtual keyring, I can say user ID / star space SSH01. And I'm using the space. I'm using the OpenSSH format. Oops. Or if I'm referring to my certificate, I could just say star space and then the label name, because any certificate is automatically connected to here. I don't actually need to create a key ring and connect the certificate. In fact, once you start doing this, you realize that doesn't buy anything, and just use virtual key rings for everything, or at least I tend to do that. We'll see later when we talk about permissions. There might be reasons why you want to use key rings, because the RACF authority to access certificate is based on the ring name. So you might want to. There are cases where you may want to use rings, but in general, most people would probably prefer to use virtual key rings. So let me do a demonstration now of doing this live. We've talked a lot about it. I have here's a 3270 session. I'm logged into a RACF administrator user ID. I'm going to create a key ring for Kirk, this user ID, but I'm not logged in as Kirk. I'm going to log into I'm going to submit this job under a RACF administrator user ID. And here, what I'm going to do is I have a delete. I'm going to delete this certificate because I run this over and over again for this demo, and I want to clean out the old one so I can create the new one with the same label. In this case, I've specified multiple, more complete distinguished name with an organization, a unit, and a country. And basically, otherwise, it's just like I showed you before. Here's something. If you have these classes rack listed, you got to refresh after you do this, of course. And then I'm gonna list all the user certificates for Kirk after I've defined this. So let me go ahead and submit this. And so it deletes it and then redefines it. You don't get any messages if it works, right? So here it is. And didn't need to rack list it. Now I'm listing all the certificates. Now this first one, that's not the one I defined. That's another one that I use. This is my standard one that I use. Paging down, here's the one I just defined. And it's got, here's my expiration date. The start date is today. My DN, key type, non-ICSF. That means the private key is stored encrypted in the RACF database set. database, but it's not stored in ICSF hardware, and there's the key size. So great, we got that. Now the next thing I'll show you is let's go show you how to use it. So for Unix stuff, I always use a SSH session. So I'm logged in with SSH to a ZOS, and I have a ZOS Unix shell here. And I'm going to go into my .ssh directory, and I want to export the public key from that RACF certificate that I created. So I'm going to use this command of ours, saf-ssh-agent-x. Here's the file. I'm just going to test1, that's the label. Lowercase is fine, I guess. Public, here's the name of the file. And then I give a reference to the certificate. Now, since for this I used a virtual key syntax, I can just say *:test1. Now the label names are case sensitive, so I got to make sure I do that right. So now I can look at this test1.pub. There it is. That's the thing that we have seen before. It's got the type and then this base 64 encoded public key. And then after that is a comment, anything you want to put. So when we actually put the distinguished name field out here as the comment from the certificate. Okay, so now that I've got that, I want to go and put that onto the server and then show you how to use the certificate to log in. So let's log into remote server. I want to be Kirk@demo. Great. Now, first thing I'm going to do is I'm going to change into the .ssh directory. I have nothing in there, right? So there's not an existing authorized keys file. I don't have to worry about overriding it. If I had one, I'd have to transfer it and then log in and concatenate it on the end. But I don't have one, so I can just take that public key file and put it out there. Before I do, I got to make sure I turn on ASCII to EBCDIC translation in the client, because on ZOS it's a text, it's an EBCDIC, and it needs to be ASCII text on this client. This remote server is a Linux box. Okay, so then I'm going to do a put of test1.pub, and I'm going to rename it as authorize. Okay, let me do an ls-al and see what I got. So authorized keys, right? Read, write. So only the owner can write to it. Good. That's what we want. And the dot directory, the .ssh directory, it's got 700. Only the owner can read it or write it or even search it. So that's good too. That's what we need to have. That all looks good. So I can quit this SFTP session. Now I'll just log in again, cozy SFTP, and well, let's just log in with SSH. Let's log in with just ported tools SSH, and I want to give the name of that. I want to use the ported tools syntax for referring to that key. So I say -o. This is the option identity key ring label equals identity key ring. Okay, now. The funny thing about this keyword on the ported tools is you got to have a literal double quote in there. It's really weird. So I have a double quote for the shell, and then I got a backslash. I got to have a literal double quote, and then I can put star space test1, and then a literal double quote, and then a quote for the shell. Right? Very strange. It's kind of annoying. Dovetail.com. I'm sorry. Boom. So it logged in the remote system, didn't prompt me for a password, and it's used that certificate to do it. Great. So I'll disconnect from that. That seems to work fine. That's what I wanted to show you. All right, so the next thing I want to talk a little bit about is the other side, the first kind of authentication, host authentication. So if you wanted to have your host's private key in a certificate instead of having it in, etc SSH there, if you want to, instead of a file, you could do that too. And the way you do it is basically the same. You use rackd-cert and you create the certificate. You give it some distinguished name, and typically you might want to name it with, it's SSHD, and here's the domain name, maybe the LPAR, whatever, I don't know. Somehow uniquely identify that SSHD or, whoever's using that key. Again, it's going to be an RSA key with this size. You can expiration date and the label that I want to identify it as, right? So it belongs to SSHD. SSHD would need to be the user ID that the SSHD started task runs under, the super user ID, that user ID, because it's going to be his private key. He needs to be the one to be able to access it. Now, here's an interesting point. This is the same as doing the user key in terms of rackf command. We're just giving it different names. And we can use virtual keyring. So I can refer to this as star space SSHD01 with the label. I can export it the same way. So everything is the same to use this. The only other thing I've got to do to use this, once I've got the key in there, to actually hook it up is, here's a diagram. On SSHD, he's the one that has the private key. Then in his etc SSH, the ZOS specific configuration for SSHD, this file, there's this keyword in here, and I give the, since he's running under this, I can leave the SSHD /off, but I want to put it in there. I probably put it in there just to make sure that we're talking about the right one in case someone starts to start a task up with the wrong user ID, maybe. So I'll refer to it that way, star space SSHD01. So this says that he's going to use this as his, for his host key ring label. This certificate's going to have the private key in it. I can export that to here, and I can copy it over, but also I don't need to really export it. I can just connect to this SSHD guy, and he'll give me his public key, just like any SSHD. When I connect, he'll say, you don't have a public key, you want to accept this one. Boom, I can do it that way. Once I've accepted it, it goes into one of my known hosts files. I put it in there with the name of the server I'm connecting to. Usually you put it in there maybe with a server, comma, and the IP address both. Then you put the type and then the public key, just like we're used to seeing. Once you do this, then what you've done is essentially you kept your server, your SSHD server's private key, you kept it out of a file system. You put it in a rackf protected database, the private key for that. Okay, so let's look now at the SAF, the rackf permissions that a user needs to access and use a certificate in a keyring. The one thing I'll mention is that the security for certificates is at the keyring level or globally, right? You can't put permission on an individual certificate, an individual label. So the ring specific is the most granular way of doing this, and this is not generally done. I'll show you in the next slide the more popular way of doing this. But sometimes this makes sense. So the ring specific way of doing this is I can have this class rdatalib. I have an entity which is the owning user ID of the ring, the name of the ring .lst, and if I grant read access to that, then the user ID himself, if you grant read access to it, he can use it. For another user ID to use a specific profile, you have to give a different user ID that is not the same. You have to give him update authority. And this is the case actually where you might want to use this. You might want to have multiple ZOS user IDs be able to use the same private key to connect to some trading partner. So you might want to use a ring-specific profile for that, because the certificate would be owned by some user ID, but then you might want to allow other user IDs to use it. So you might do it this way. And if you did that, you would probably want to create a key ring for it. Although in this case, you can also say, I want to connect a specific profile up to the virtual key ring, the star one, and you use this special name in the resource to do that. So you want to think about this, because this would allow you to, if you give update to another user ID, they could access any certificate that belonged to that user ID through the virtual key ring. Might be a little bit dicey. If you don't have a specific profile, it checks that first. If there isn't one of those, then it checks the global profile. And the way this works is you set up a resource for class facility. The entity name is this. And if you give a user read access to this facility, then he can use his own key rings, his virtual key ring or his own specific key rings. If you give a user update to this, then he can use any user's key rings, right? So, yikes, that's why I put yikes there. That's you wouldn't want to do that unless you really thought about it. Okay, so now we talked about the permissions. This is something that is extra on top of what we've already discussed. And what we're doing here is showing how when you generate a certificate, you can add a keyword. You can add either the PCI-CC keyword or the ICSF keyword, either one. They're very similar. Look at the documentation for the details, but I think PCI-CC says to use a coprocessor card to generate the key and then store the key in an ICSF token, whereas ICSF, I think, says use ICSF to generate the key and then store it in a token. So in both cases, the private key gets stored in ICSF hardware. By default, the private key is stored in the hardware with a token name that's the same as the label name on the certificate, right? So that's why you want to maybe look at, and the namespace for that is a little different than label namespaces, so you have to be careful. You can also specify a parameter on these ICSF or PCI-CC. You can give it its own token name or label name for the hardware token. I tend to just use the same name. So now, when you do this, what's different about this and what we did earlier? The key difference is that because the private key is in hardware, the user, this Alice, right, cannot get the private key from his own certificate, her own certificate. Cannot read the private key. They can use it. They can make an API call to use the private key, but they can't get the private key material out and see it, right? But if you do this and you put it in hardware, Ported Tools OpenSSH cannot, on its own, with what we showed you earlier, using identity keyring label or host keyring label, it can't use a certificate private key unless it can read it. That's an unfortunate fact, but that's just the way it works for now. So how do you deal with this? Well, again, we have this thing that we showed you. In fact, the SAF SSH agents part of Cozy, we had available, somewhat before even 1.2 came out. You could use this with the old Release 1 version of Ported Tools before IBM had key support, RACF key support. So using this, what we do is we use this protocol in OpenSSH called the SSH agent protocol. And this is a private Unix domain socket protocol so that the SSH client can talk to another program that does the user key operations, right? So when you use the SSH client, you have to configure it and tell him, okay, here's how you talk to this agent, and the agent gets to say, well, here's the public keys that I have, and the SSH uses those to negotiate the session, and then it comes back to the agent and says, okay, here's the thing I want you to sign, and the agent signs it and sends it to the SSH thing, and he sends it on and does it. So basically it offloads the user's authentication key operations to an agent. And this is used heavily if you've used SSH on a desktop where you have the SSH running and you unlock your private keys and you have multiple SSH sessions that can use this sort of running agent that's authenticated maybe with your desktop. Maybe it's got a hardware token card on your PC or something. So the agent, is kind of a cool thing in SSH. Now, our agent for using SAF, all this setup, if you're using Cozy SFTP, it's real easy. You just say -K, this option -K. You give it the name of the ring, colon, and the name of the label, and it'll automatically set up an agent before it invokes SSH under the covers. I'll show you a little bit of how that looks. If you're using Cozy Launcher, you can just use this property to set this up, and we automatically configure the agent. Or you can even use this command -C in front of an SSH command to wrap it with an agent so that it can use our agent. So when you use SAF SSH agent, using an agent to do the key things as an alternative to using the built-in identity keyring label keyword or the host for Ported Tools SSH. Little bit. I hope I'm not going over this too fast. So I'm not going to go into this in detail, but this is kind of a diagram of how it works with Cozy SFTP. So when you connect to, I'm going to use this certificate SSH01 on my virtual keyring to a host. Underneath the covers, it starts the SAF SSH agent process, right? And he opens up that keyring, and he also sets up a private Unix domain socket like this. And when then the next thing he does is he starts the SSH client. This is the Ported Tools SSH client, because SFTP always does it. He starts SSH underneath the covers to do the lower level stuff. But when he does that, he sets an environment variable that points to the socket name so that now SSH knows, okay, this is the socket I talked to my agent on. And then, the agent, our program is we use the systems SSL library, this GSK APIs, to do the keyring operations. In particular, we call this thing called sign data, which drives down through ICSF down to the coprocessor if you have one, and makes the signature without reading it. Okay. If you want to use our SAF SSH agent for your user authentication, and by the way, it only works for user authentication. The agent protocol only is there on the client for user authentication. But if you want to use that, you also have to have these permissions in the CSF serve class. This is the ICSF service. DSG and DSV are the digital signature generate and verify, because we're making ICSF calls to do that as part of using a key. So you got to have those permissions if you don't have them already, so that you can use ICSF for that. And actually, even if your private key is not in hardware, if you use SAF SSH agent, we always call these ICSF calls. So you need these permissions if you use SAF SSH agent. Okay, so let me just show you a quick demonstration of that, what the difference is on that. So here's how I did it right using SSH with the identity keyring label. So let's change this. Let's do Cozy SFTP. Let's use this -K means we're going to use the SAF SSH agent. Here's the virtual keyring and the label, and then I'm just going to put Kirk. I hit something bad. At demo. Yeah, it somehow wrapped it. That's actually a Cozy SFTP command. It slid it over, but so that worked, right? So I can reference this keyring, this label through there. Now, this command would work even if I put the private key in hardware, whereas the earlier one, if I put the private key in hardware, it would fail. It would say I can't read the private key. It would get an error like that. Okay. All right. So this is we're just about done here. This is a very high level sort of overview of what we consider some best practices for using keys. First of all, I think it's really a good idea to use certificates for your private keys. I think it's just most security administrators will agree. I think that using a file system for that kind of thing is just not a really good idea. So I think that using certificates for private keys is a good idea. Now you might also want to, here's another bullet point, for really sensitive stuff, you might want to use it if you have a hardware coprocessor. You might want to store the private key in hardware and use SSH agent. I think we're recommending our Cozy customers that you could just use SSH agent for either kind, for either the ones that don't have a private key in hardware or do. It works equally well for both. The syntax is a little easier to deal with. And then if you ever decided to move it and change it, you don't have to worry about that. When you're using digital certificates, you have to worry about when they expire, right? Because even though the X509 certificate is not exchanged across the wire, ZOS, RACF, and the RDatalib, it won't let you use the certificate if it's expired. So you can't even get the private key out and use it if the certificate's expired. So you have to do one of two things. You have to, have a calendar entry or something that says, okay, you got to renew your certificates before they expire. IBM actually has some products that sit on top of ZOS that do certificate management that'll handle all this, renewal notices and stuff like that. If you're using that as part of a CA on ZOS, that might be something you might want to use. In our documentation online, where we talk about using certificates with SSH, we have an example of the command that you can use to renew a self-signed certificate. Now, as far as I know, you have to do this before it expires, so you can't actually, renew a self-signed certificate that it's expired. You need to do this before it expires. So this is a way to extend the date. Now, if you don't want to extend the date, the other thing you can do is you can transition. You can have an old and a new, and you might want to create the other one and start publishing it out, to one side, and then you can actually have more than one, like in known hosts, you could have more than one public key that your clients know, the old one and the new one, and then you would switch over on the other server and flip the switch so that in the transition you can have an old and a new that are both supported in the interim. I mentioned this, and finally, we talked a lot about this in part one, but it's really important, I think, internally, if you have a large network, an internal network of SSH servers, I think it's really important to, collect a master list of all your SSH known hosts and publish those to your clients, your SSH clients, or put them on a secure website and have the clients automatically, in a cron job, pull them down, or however you want to distribute those. And we talked a lot about that in part one, about options for that and some of the future options of maybe using SSH FP records in the DNS for this instead, if you have DNSSEC. So you might want to look at that. This is a kind of a big deal. It's not related to what we're doing today, but it's just part of the overall thing you need to worry about when you're using keys. Okay, so that's basically all we have. And I know that this, this is very high level, these best practices. So what we would invite you to do is, if you have more questions about this, of course, you can look at the documentation, but we also have a community forum, a bulletin board that you can ask questions about this stuff. We'll be happy to help you there. If you're a commercial support customer, please open a ticket. That's a good idea to do that. If you have a question, we'll be happy to discuss with you, what you're trying to do and work through any issues you have with best practices. our archives, which we mentioned, you can see part 1 of this presentation, and we'll have this actual recording up there shortly. And I guess that's all. So thanks for your time, and I appreciate everyone who was able to attend both last week's and this week's presentation. And I guess that'll be it. So thanks.